Now students, and I want to add the methods of preparation of the alcohol. Although I have explained the preparation of phenol and you can see chemical properties of the phenol, and then method of preparation of the alcohol. Right. So you write down methods of preparation of, what is that? Alcohol. First is the, you can say, reduction of aldehydes and, what is that? Ketones. Aldehydes whenever reduced, primary alcohols are formed, and ketone whenever reduced, secondary alcohols are formed. You take any reducing agent, lithium aluminum hydride, sodium borohydride, zinc on HCl, nickel, platinum, palladium, etc. So it is the aldehyde, CS3, CS double bond, ethanol, al is the aldehyde. You can say it is common name, what is that? Acetaldehyde. You take two nascent hydrogen, reducing agent you can take sodium borohydride, one H will be here, other H will be there. CS3, CH, CH2 and OH. What is that? Or you can say CS3, CS2OH. What is formed here? Or OL is the alcohol, but it is the primary alcohol. So aldehyde produce primary alcohol. So far as ketone is concerned, CS3, C double bond O CS3, take 2H here, right? So you can take here lithium aluminum hydride. One H will be there and other H will be there. LAH, short form lithium aluminum hydride. So here CS3, OH, H, and what is that? CS3, 1, 2 and 3. This is the 2-degree alcohol. Propanetol, isopropyl alcohol, propanetol. So the method of preparation you can go for the reduction. Second is the reduction of carboxylic acid, CS3, C double bond OH plus 4H. You can take lithium aluminum hydride. Water is lost here, H and 2H. Then dear students, you will get ethanol. Third is the reduction of ester. Reduction of ester. You know the formula of the ester? CS3, COO, C2H5. Now you take 4 hydrogen in presence of the any reducing agent, where it forms CS3, CH2OH plus C2H5OH. Again you get the reaction is balanced. You get the 2 molecules of ethanol. So reduction of acid, reduction of the aldehydes in ketones, and reduction of, you can see, what is that? Ester. Fourth is the commercial method, is the hydroboration oxidation reaction. Hydroboration oxidation means addition of propane, addition of diborane on propene, addition of diborane on propene with hydrogen peroxide, contrary to the Marconi-Cope rule, to form propane 1 or as an excellent yield. This is called hydroboration oxidation. It is also the worldwide production of the alcohol. So you take CS3, CH double bond CH2. Further 3 molecules we take here, propane, propene and propene. How many molecules propene we took here? How many molecules? 3 molecules. And then you have to add here, this is the BH3, right, plus BH3. Then the students here that this H and this H will be there. It is a 3 molecule propane, CH3, CH2 boron is the trivalent, CH3 and CH3, and then it is like this, and then CH3, CH2 and CH2. So tripropyl borane, it is the tripropyl borane. Further it is made to react with hydrogen peroxide, hydrogen peroxide, to form here addition with H2O2, hydrogen peroxide. That H2O2 can be added like this, HOOH. How many times? 3. What is lost here? BOH whole thrice plus OH. How many times? 3 times. Added here 3 molecules, CH3, CH2, CH2OH. As an excellent yield, propane 1-off. Or BOH whole 3 is also called as H3BO3, orthoboric acid. It is the ortho, write down, boric acid, or it is antiseptic. Ophthalmologists, the doctors which operate eyes, ophthalmo, used to take mild H3BO3 to clean the eyes. It acts as an antiseptic, orthoboric acid. So 2 equally important products are obtained and highly acclaimed commercially products compounds. Therefore, it is hydroboration oxidation. It's very important reaction. And then illustrate an example with hydroboration oxidation. Fittig shared the Nobel Prize with Wittig. So they also received the Nobel Prize for the preparation of this. Next is the very important is the from Grignard reagent. It is such an important and unique method. Victor Grignard prepared such a wonderful reagent and obtained 3 types of the monohydric alcohol. 1 degree, primary, secondary, and what? Primary, secondary, and 1 degree, 2 degree, and 3 degree alcohol. Right? First of all, you take, see, this is important for your paper, CH3, Mg and Br. Right? It is one of the important Grignard, methyl magnesium bromide. And this is the CH2O. Actually, it is called as methanol, or you can say it is the formaldehyde. Whenever this methyl will be added here, CH3, CH2O, Mg and Br. It is the adduct. It has no nomenclature. Further, water is added here, so this H will be there, and then CH3, CH2OH plus MgOH and Br. It is what degree alcohol? 1 degree alcohol. So once you take Grignard plus formaldehyde, primary alcohols are formed. But any other aldehyde, then the formaldehyde. Either you take ethanol, propanol, butanol, you take only 2 degree alcohol. But for 1 degree alcohol के लिए सिर्फ हमें चाहिए formaldehyde, right? And for 2 degree alcohol, you take any aldehyde other than the formaldehyde. So dear student, here I take CH3 MgBr plus acetaldehyde. It is called as, what is that? Ethanol or acetal what? Acetaldehyde. So write down properly here CH3 CHO, Mg and Br. What is that? Adduct is formed. Right. So further you go for hydrolysis in acidic medium. Right. So it is what? This H will be added there. Right. And then plus MgOH Br is out. CS3, CH, and what is that? OH. What degree alcohol? It is known as isopropyl. What is that? Alcohol. For dear students, it is the 2-degree alcohol. So that for the tertiary alcohol, you further take Grignard reagent CS3 MgBr plus CS3 C double bond O. It is ketone. For 3-degree alcohol, you remember, you take ketone. 2-degree alcohol, any aldehyde other than the formaldehyde. So the way you can get it here, like this. Now this methyl will be added here. Total 3 alkyl, CS3 and CS3, O, Mg and Br. This is the adduct further. Hydrolysis with water. Then it forms MgOH and Br. Then this is H will be here. Then it forms, what is this? Tertiary butyl alcohol. Tertiary butyl alcohol. It is tertiary butyl. What is that? Alcohol. Write back name. This is the 1. This is the 2, or this could be 3. What is that? 2-methyl propane 2-ol. So that is what? From the Grignard reagent, you remember, for 1-degree alcohol, formaldehyde, for 2-degree alcohol, what is that? Any aldehyde other than the formaldehyde, and for 3-degree alcohol we take ketone. So all the methods of preparation are finished except one. What is that? That is hydration of the ethene by taking mechanism. Hydration of the ethene by taking what? Mechanism. So last method you write down. Hydration of ethene. See, important method and its mechanism. Right. Mechanism. So you take first CH2 double bond CS2 plus water in acidic medium or dilute H2SO4, CS3 CS2OH. This is the ethene to what? What is formed? Ethene to ethanol. Now mechanism is believed to be in 3 steps. First is formation of carbocation. Take this here. Water is like this. It has lone pair of electron and H positive charge here. So water acts as a nucleophile and acts as the electrophile. So there is possibility of the reaction. So this lone pair of electron is being added to this H ion and it forms positive charge and lone pair like this. Or you can write H3O positive. This is hydronium ion. You take the ethene here, CH2 double bond CH2. Whenever you take the ethene plus OH and the H, this lone pair, this one electron is being, one pair of electron is being donated to the hydrogen, and hydrogen will provide the electron to this one. So therefore CH3 CH2 positive charge plus water. This H will be taken back to this carbon. CH2 becomes, what is that? CH3 CH2 positive, and nucleophile is being signed here because of Carbocation. Our purpose was to get the carbocation. This is actually ethyl carbocation. It is called as ethyl carbo. 2. Second is the formation of carbocation. Third is the attack of nucleophile. Attack of nucleophile. So take this one, CH3. What is that? CH2 positive, and water acts as a nucleophile because it is the resource of the electron. So this electron is being donated here, then it forms CH3, CH2, and what is that? OH2, but positive charge in lone pair of the electron. So this is called as ethyl oxonium ion. Ethyl oxonium ion. Now the last mechanism, last step is the deprotonation. What is that? Deprotonation is that loss of proton. CH3, CH2, OH, positive charge, and this this H will donate the electron to the oxygen. H ion will be lost. It forms, that is the CH3, CH2 and OH. This is, or it is called as H3O positive. So this is the ethyl alcohol. So dear students, to go through the mechanisms. First step is take ethene and water in acidic medium or dilute as to so ethyl alcohol is obtained. Question is, write the mechanism of the formation of the ethene to ethanol or ethyl alcohol. Therefore you take ethene, take the hydronium ion, and it forms ethyl carbocation. I have already mentioned here. Attack of the nucleophile. Ethyl carbocation, whenever added to the you see water acts as a nucleophile, so it forms ethyl oxonium ion, and then this deprotonation, I mean elimination of proton or the loss of protons. So you take this H will be out in the form of the aqueous medium, so H positive becomes hydronium ion and ethyl alcohol is obtained. This is all about. You consider the formation of the Grignard reagent, mechanism of the ethene to ethanol, reduction of the aldehydes and the ketones, reduction of the carboxylic acid, reduction of the ester, and the hydroboration oxidation. All the methods of preparations are over, and before it I explained you the chemical properties of the alcohol and the phenol, and then next we give you the lot of content on videos, ether formation and the properties of the ether. I will repeat all these things further so that I want to make your concept very clear. I hope you will go through all that contents unless and until you will not remember the organic content. Right. Thank you very much. Have a nice day to all of you. Okay. Bye.